So let's look at a quick summary of what we've learned by looking at the weak acid strong base titration curve. So remember that the starting point, or when we've not added any strong base at all, the pH is determined completely by the Ka equilibrium of the weak acid. So in this case, we're looking at acetic acid, so the pH is equal to 2.89. So because different weak acids have different Kas, the starting pH is going to be different for different weak acids. After that, remember during these titrations, after we've added in sodium hydroxide or hydroxide, our strong base, the first thing I want to do is look at the relative amounts of the weak acid that we started with and the moles of strong base that we have added. So if the number of moles of strong base is less than the number of moles of weak acid, that means that we are somewhere in between our starting point and our equivalence point, and what we want to use is the Henderson Hasselbalch equation. So we want to do the subtraction, say how many moles of weak acid do we have remaining. We understand that weak acid is being converted into conjugate base. We find the number of moles of conjugate base, and then we plug in the moles of weak acid and the moles of conjugate base into our Henderson Hasselbalch equation. The next point that we're interested in is when the moles of strong base added is equal to the number of moles of weak acid that we had initially. We now know that we are at the equivalence point. So when the moles of weak acid that we started with initially is equal to the moles of strong base that we added during the titration, when those are equal to each other, we are at the equivalence point. And here, what happens is the pH is determined by the concentration of the conjugate base. So the whole idea flips around. We've completely converted our weak acid into conjugate base. So now the conjugate base is what determines the pH. And so beyond this point, really the fact that we're dealing with a weak acid doesn't matter anymore. So when the moles of strong base are greater than the number of moles of weak acid initially, so we're past the equivalence point, here it's completely determined by the concentration of hydroxide that remains. So it doesn't matter if we're dealing with a weak acid or a strong acid, it's just acid. And what we want to find now is the number of moles of strong base that remain. So we subtract, or we start with the number of moles of strong base, we subtract the number of moles of weak acid that we had initially, and then what we will do is find the concentration of that hydroxide, and then from that we will find the pH.